Okay, so you're back from Manu Sporny's Semantic Web intro. Now, let's dig in a little deeper. So our two main components in the semantic web are ontologies and instances. Ontologies specify classes, their attributes or characteristics, and the relationships that members of a class can participate in with members of other classes. Instances take the classes that were invoked and described in ontologies and apply them to specific resources or data. So if you wanted to do something on the semantic web, first you would need to create an ontology that declares your classes and relationships. Relationships are known as object properties, and characteristics or attributes are known as data type properties. You'll see some examples of both in the example ontology in the Session 9 folder. And this ontology that we're working on right now, which is not really an ontology, we're just going to define some classes for the sake of conversation. We're defining a class called car, a class called manufacturer, and we state that there's a relationship between a manufacturer and a car called made by. Then we get down a level in granularity, and we create an RDF document that instantiates the classes in our ontology. The class of car has an instance called Jetta. The class of manufacturer has an instance called Volkswagen. And now we can say that Jetta is made by Volkswagen. The instantiation of the classes and the statement of the relationship can happen in the same document or in different documents. It makes no difference. Okay, so like it says, ontologies are the backbone of the semantic web. When I say that an ontology is a thesaurus, it's really true. A thesaurus, which we'll see in more depth next week, takes concepts, it usually defines them, and describes the relationships among concepts. In both cases, the vocabulary of the realm is declared in the ontology or the thesaurus. And like I say, notice similarities and differences in the use of the word ontology here in the sort of computer science semantic web sense, and then earlier this semester in the philosophy sense. So in the philosophy sense, ontology is the study of things in existence. In the computer science sense, an ontology is a document that declares classes, their attributes, and relationships among them. So to create a computer science ontology, one must practice the philosophical exercise of ontology. So that's sort of the relationship on how that word gets used two ways. Okay, now would be a good time to take a look at the ontology I provided in the Session 9 folder. It's a PDF file called Freedmen's Bureau Ontology OWL. This ontology has been annotated throughout to point out different features to you. The basic organization of the ontology is that after the namespace declarations, which you don't need to worry about right now, are the class definitions. The first classes that get defined are ones that have previously been defined in other ontologies, and this ontology states that it is accepting and adopting these previous definitions. This capability is huge because it allows for any number of applications to agree upon common definitions of concepts. The next set of classes in the ontology are the ones that are being newly defined in this ontology. Each class definition declares its parent class by saying that the new class is a subclass of another class. The RDFS comment is an unparsed comment that can be used in any way. In this case, it's similar to a scope node in a thesaurus by describing in human language the definition of the class. As you read through this ontology document, like with doing the XML, don't be trying to learn this programming language. I know it's difficult to get through. Instead, just read to get a sense of what's being said. I've tried to do a lot of translating in the annotation boxes and the margins. Pay attention to those, and if the concepts don't gel for you, ask for help on the message boards or bring your questions to class on Thursday. I would also really like for you to start looking for connections between what you see in this ontology, the Freedmen's Bureau ontology, and what you saw in the RDF spec and the Owl Wine ontology that you had for your readings tonight. Those should sort of help you kind of figure out how some of these relationships are defined. If you see something in the Freedmen's Bureau ontology that doesn't make sense, see if you can find it in the wine ontology or in the OWL specification, and you might be able to read a useful definition of what it is and how it works. Okay, so let's wrap up. As we saw before, an ontology is like a thesaurus because it identifies and defines concepts and the relationships among. The language is more clunky, as you saw in the Freedmen's Bureau ontology and the wine ontology, but that's because it's being rendered as computer readable instead of being human readable. An ontology can also function like a metadata schema, just as a regular XML schema can function like a metadata schema, because it specifies the characteristics of a resource that can be described. A metadata schema is like a blank template for creating metadata records, and ontology is sort of like a template for creating RDF statements. It's saying what the things are that you can make statements about and what kinds of relationships you can make among those things. So that wraps up our presentation for tonight. As I said, you are encouraged but not required to participate in the message boards for this week, and I would really like to see some folks generate their own conversation topics, whether in the Session 9 forum or on the student-to-student forum. When we get together on Thursday, we'll get into indexing languages and thesauri after we talk through any remaining questions or observations or discussion that you guys have about the Session 9 presentation. See you Thursday.